Hi everyone, in this video session we will have a discussion on power electronics questions which was asked in GATE 2023. This question belongs from the chopper. The chopper circuit shown in figure feeds power to a 5 ampere DC constant current source. Okay, the switching frequency of a chopper is given 100 kilohertz. All the components can be assumed to be ideal. The gate signals of switches S1 and S2 are shown in figure 2. This is gate switches signal. Average voltage across the 5 ampere current source we need to calculate. See, we need to find what V average across the 5 ampere current source. So we need to see when S1 is on, one second guys. In question I think gate signal for S1, then this should be S2. Correct? This should be S2. Okay, then now figure 2 is correct. So S1 is on and S2 is off. Then what? Then voltage across the 5 ampere will be V across the 5 ampere. What we can say? V 5 ampere equal to 20 volt. But when? At the time when your S1 switch will be on. Okay. So S1 is on for 0 to 3 microsecond. Okay, that means T on for S1 is 3 microsecond. Total time period we can see, this is the total time period for S1. So it is 10 microsecond. So total time is 10 microsecond. V across the 5 ampere source is 20 volt for 3 microsecond, and after 10 microsecond again there will be pulse of 20 volt. Okay, so this is the curve. So we need to find average of this. So average, V average is nothing but area under the curve divided by time period. Correct? So V average will be area 20 into 3 microsecond divided by 10 microsecond. So 0 to 0 and microsecond cancel out. So 6 volt. So 6 volt will be the average value of voltage across 5 ampere current source. So see which option is correct. Option B is correct. Okay. So this was a very easy question from chopper. We will move to another questions which was also from the power electronics, and it is from fundamental of power electronics, where we need to understand that what is bipolar switch, what is unipolar switch, what is unidirectional switch, what is bidirectional switch. Okay, A semiconductor switch needs to block voltage V of only one polarity. One polarity. That means it is unipolar. Unipolar. Okay, it is unipolar. During off state, as shown in the figure, carry current in both direction. In during on state, that means your switch is bidirectional. Bidirectional as shown in figure 2. Which of the following switch combination will realize the same? ठीक है, this question was MSQ. This was MSQ. So in this question there is chance to have multiple correct option. So we need to be very much careful. ठीक है, तो what if they are asking that your switch shall be unipolar and it shall be bidirectional. That means a block करेगा voltage in one direction, say this direction, and current will be carried by it in both direction. Let's see. From option A we can see in off state voltage will be blocked, ठीक है, only in this direction. Correct. So it is unipolar. It is unipolar. And current will be carried in which direction? If your BJT will be on, current will be carried like this way. Okay. And when BJT will be off, diode will not block this polarity voltage. This polarity voltage will not be blocked, but it will carry this direction current. Hence, it can carry bidirectional. Whole switch will carry bidirectional current. So option A, switch is unipolar and bidirectional. So as per our question, option A is correct. Now since it is MSQ, we have to check each and every option with very much careful. So now if you will see this question, option B, in this you will see two diodes is there, but if current wants to flow in this way, is it possible? No, current cannot flow in this direction due to this diode. If this diode is available, we cannot make current flow towards the Q, but current can flow Q to P in this way. Okay, so this switch is what? Unipolar and unidirectional. Unidirectional, which is not our requirement. Hence option B is wrong. Let's check option C. BJT will block this voltage. Okay, and this diode will help to flow current towards the Q point from P. So this current direction will be correct and polarity will be blocked in this way. When current wants to flow from Q to P, it is not possible since this diode will block the current. So this switch is also unipolar and unidirectional. Hence option C is also wrong. Now come to option D. This polarity will be blocked by BJT and current will be carried P to Q this way. Correct? So one polarity voltage will be blocked by BJT and current will be carried in P to Q direction. And if we want to check current direction from Q to P, let's check. So this diode will help to flow the current towards the P point from Q point. Hence we can say that this switch is bidirectional. This switch is bidirectional and unipolar. Hence this option D is also correct. So for this question there is two option which is correct. So you need to select A and D to get what? To get marks in GATE examination. ठीक है. If you will miss one correct option, you will get 0 marks. So be careful when it is MSQ. You need to check each and every option, okay, which is correct and which is wrong, and you need to select all the correct option as per question. Then you will have full marks for assigned question. Now we will move towards the other problem which was also asked in GATE 2023 and it is from power electronics. See, the circuit shown in figure has reached a steady state with thyristor T off in condition. See, this circuit is in a steady state. It is already given. Assume that latching and holding current of thyristors are 0. So latching current and holding current is 0. They have given. The thyristor is turned on at t equal to 0 second. t equal to 0 second पर thyristor क्या हुआ है? On हुआ है. The duration in microsecond for which thyristor would conduct before it turns off. Okay. So see what is the situation. When it is case 1, there will be two situations. First is your T will be, thyristor will be off, and this is what? Capacitor. This is the situation. Okay. So since it is ideal condition, inductor will be behave as a short circuited and capacitor will be opened. So there will be formation of 100 volt towards the capacitor when your thyristor is turned off. When you will take case 2, circuit will look like this, 100 volt, and thyristor is on, so it will be shorted, and this is 4 ohm, so 25 ampere will flow through 4 ohm, and capacitor will be charged like this. So see, this thyristor will carry what? 25 ampere, okay, due to the connected load 4 ohm, and this thyristor will also carry a current of this circulating circuit. Like this circuit, capacitor and inductor circuit is closed in nature, so capacitor will pump some current Okay, so one current will flow like this. So total thyristor current when your thyristor will get turned on is what? 25 ampere plus capacitor voltage VC under root CYL sine omega naught T. Correct? So total current is 25 ampere plus BC 100 volt and C is 1 microfarad and L is 4 microfarad. So this much is the current which will flow when your thyristor is turned on. So to get the time period for which thyristor is on, we need to make total current thyristor current equal to 0. So from this expression we can say that omega naught into T on will be what? Sine inverse of minus 25 divided by 50. It will be 7 pi by 6. So T on will be 7 pi by 6, okay, into omega naught, where omega naught is 1 by under root LC. So we can say that 7 pi into under root LC divided by 6 is the time period for which your T thyristor will conduct. So T on in microsecond 1 into 4 microsecond divided by 6. It will be it will be 7.33 microsecond. So this is the duration for which thyristor would conduct before it turns off. So answer is 7.33, and we need to round off to decimal 2 places. So whenever you solve these kind of questions, take care the unit if they are asking in millisecond or they are asking in microsecond, okay, and also take care the round what till what decimal places they have asked to round off, okay, and with these two care you will get full marks. Since if we solve the question with perfection and we miss in unit, it is a very bad practice, and sometimes we can make that kind of mistakes. So always take care that what is the unit of a final answer we have got and what they have asked. Based on that you need to insert your value. Now let's move over another problem which was asked in GATE 2023, and it is from power electronics. See, in this also there is two situations. We can say these kind of questions can be solved with the output waveforms. So the single phase rectifier consisting of three thyristors T1, T2, T3 and a D1, diode D1 feed power to 10 ampere constant current load. T1 and T3 are fired at alpha 60 degree and T2 is fired at 240 degree. The reference for alpha is positive zero crossing of V in. The average voltage V naught we need to calculate, and we need to what, round off to the two decimal places. Let me draw the waveforms, then I will discuss. Say this is the waveform of V in, and this is the alpha 60 degree, and this is the 240 degree point. Okay, and this is the pi, and this is the 2 pi. This is V out. So for 60 degree to pi, if we will look at the circuit, how it will looks, just have a realization. Say that this is V in. Okay, this is V in. T1 will be on. Okay, T2 will be off, and T3 will be on, and load will be connected like this 10 ampere. Okay, so here T1 and T3 will conduct. Okay, when at pi there will be reversal of supply voltage, then T1 will get turned off, but your 10 ampere will be there in the connected circuit, so it will flow through what, it will flow through D1 and T3. So this way it will flow. Okay, it will flow. Then at this time V output will be 0. Hence here this is the 0 voltage. Okay, now let's have a look. When T1 and T3 is off, now at 240, when T2 gets fired, what will happen? T2 is on. Okay, T1 is off, D2 will conduct, so it is D1 not D2. D1 will conduct and D2 will conduct. Okay, and 10 ampere source will be there, so current will flow like this, correct? when here if you will see, since T3 is reverse bias and it is not conducting, and now as T3 is a thyristor, to conduct thyristor we need to fire it so that it gets on, but it will not on since T3 will be fired at 2 pi plus 60 degree. So till next 60 degree there is like here D1 and T2 will conduct. Here what? T2 bonds to turned off. At this point T2 will try to get turned off, but connected 10 ampere should flow some through some circuit since it is a current source. If there won't be any path to flow 10 ampere, at that time KCL will violate. Hence 10 ampere continuously will flow through T2 and D1. Okay, so at this point also your T2 and D1 will conduct. ठीक है? So due to that region these spikes come and negative spikes came in this problem. Okay, so negative spikes is there in output voltage due to 10 ampere DC what? 10 ampere constant current source. This is constant current source. Hence your T2 and D1 is conducting beyond 2 pi. So with the output voltage waveform, we can calculate the average voltage. So what is average voltage? V average will be period is 2 pi and area we need to calculate. So this is the 2 period. Now we are calculating area. So alpha 2 pi Vm sin omega d omega dt plus pi plus alpha, that means 240 for our case, and it is conducting till what? 2 pi plus alpha, and at that time your voltage is negative. So Vm minus Bm sin omega t d omega t dt. ठीक है? So V naught will be Vm by 2 pi into 1 plus 3 cos alpha. This is the what? Average voltage. We cannot apply a standard formula in this question since this question is little bit twisted. So you need to understand the circuit and you need to find the output voltage waveform, and after that you need to calculate the average of that waveform and then you will have answer. So maximum voltage is what? 100 volt. You can see this is the maximum voltage. 100 period is 2 pi 1 plus 3 cos alpha is 60 degree. So it will be 39.78 degree voltage. Okay, so correct answer is 39.78 volt. So see, this question is little bit twisted, but when we understand why T1 and T3 will get turned off, why T2 and D1 will conduct beyond 2 pi. So there is a reason that to maintain the healthy circuit there must be a freewheeling path. So at the time of T1 and T3 conducting a state, when T1 gets turned off, there is a path to flow the 10 ampere current via D1 and T3. But at the time when T2 and D1 is conducting, there is no alternative path to carry the 10 ampere current. Due to that, your D2 and D1 will conduct till 2 pi plus alpha. So this stage is 2 pi plus alpha. So this way we can solve any power electronics problem which will belongs from rectifier. In rectifier chapter, we need to analyze the waveform and we need to draw. So this year gate questions from power electronics was not a difficult problem, except this rectifier question was little bit twisted, but like these problems, same concept problems already gate authority has asked in the previous year problems. So all a student can get full marks in power electronics, since every question was very much, like we can say that if your concept is good, you can easily solve. With this guys, I will close the this session. Thank you.